Alrighty, here it is. The eye, part 2. So in our last video, we went over the parts of the eye and what all the jobs of each of those parts are. But now we're gonna go over how your eye actually sees. How your eye actually sees, okay? So let's just say we've got our handy dandy picture of an eye here. And we'll pretend this is your eye. Your eye sees a balloon. So what's happening is, first off, the white light from the room, that'd be that, okay, is currently shining on that balloon. And remember, white light is actually all the colors of light, okay, but it's just combined. It's not broken down. So the white light is shining on the balloon. Then that balloon absorbs, we'll talk about just the blue part, absorbs all the colors of the light except blue. It reflects the blue light. So all colors go in, blue comes off. All colors go in, blue comes off. And reflects into your eye. Okay, so that's the light going into your eye. So the cornea bends, and obviously the cornea is protecting your eye, bends the light so it kind of focuses it. It goes through that pupil, and remember the iris is controlling how much light is in the room. There's lots of light in this room, so the iris is going to be expanded so that the pupil is smaller, okay? Then the blue light from our blue balloon, okay, goes through our eye, okay, and it is focused by the lens, okay, it focuses that image. Then it is projected onto the back of your eye, okay, projected onto the back of your eye. And because this is curved, it actually projects it so it looks like this. That balloon projected on the back of your eye is upside down. What? How is it upside down? Well, it's upside down because if you've ever noticed, like a spoon, if you're eating your cereal and you look at yourself in your metal spoon, and you look at like the curved side, right? Your face is literally upside down. So why is that? It's because the image is flipped because of that curve. So, because this is curved, the same thing happens. Your image is upside down. Excuse me. So, it goes in the back of your eye, lands on the retina. Remember, the retina has the rods and cones in it, which sense your light, your colors of light, and your shading, your shadowing. And then it creates the signal. Of, okay, I see a blue balloon with a long black string. And then it shoots those messages about the balloon, about that image, is electrical signals through that nerve, the optic nerve, okay, to your brain. And your brain unscrambles that image, and your brain goes, okay, that is clearly a blue balloon that I'm looking at. Your brain doesn't see it as upside down, or else we'd see everything in the world as upside down. But we don't. Your brain flips it around because your brain's so smart. All right, so that concludes my overall how we see spiel. So again, all the white light hits the balloon, all of it's absorbed except for the blue. The blue is reflected into the eye through the cornea, through the pupil, focused by the lens, onto the back of the retina. The retina senses the color and the shadow, creates the signal, shoots it through the optic nerve straight to your noodle, and that's how you see.